So let us discuss about orbital picture of alkanes, alkenes, alkynes, and aromatic alkanes, aromatic hydrocarbons. In this, we will be saying Kekulé structure. So we'll start with alkanes. Let us take the example of ethane, C2H6. It is nothing but carbon, carbon singly bonded with hydrogen, 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 and hydrogen, and hydrogen. As we know that carbon has 6 electrons, such that 1s2, 2s2, and 2p2 is the configuration. So its valence cell electronic configuration is 2s2, 2p2. So if we make box of it, 1, 2, and 3, and 4s. This is 2s and this is 2p. S has 2 electron and P has 2 electrons. So what happens when they hybridize? Then they mix up together. After hybridization, they mix up all together, and electrons they redistribute themselves. Electrons they redistribute themselves. 1, 2, 3, 4, like this, and it forms sp3 hybrid orbital. Due to the formation of sp3 hybrid orbital, its structure can be written as 1 carbon, is 1 carbon. Another carbon I can take with some other color, forms this sigma bond. So in this way it forms a tetrahedral structure. So this is the sigma bond. Now each hydrogen comes with 1s electron, and they have 1 electron here. It was having 1 electron, it was having 1 electron, so it is filled up. Now each of these has got 1 electron. So to pair up these electrons, what happens? 1 hydrogen comes with 1s electron, and forms a bond. Sigma, sigma, sigma. Similarly, on the other side also, 1 electron comes from hydrogen, if you carefully look at this structure, you will find that it is forming tetrahedron. See, it is tetrahedral. Again, it is a triangular plane. So it forms tetrahedron like this. because it is sp3 hybrid structure. This carbon is sp3, this carbon is sp3, so they form tetrahedral structure. Now let us see how alkenes are formed. Formation of alkenes. It is sigma bond, it is sigma bond. This is pi bond. So pi bond is formed by lateral overlapping of hybrid orbitals of pure p orbitals, whereas the sigma bonds is formed by head-on overlapping or axial overlapping of pure as well as hybrid orbitals. So, since it is forming a triangular planar structure, if this is the center of mass of the molecule, from here you see it is forming a triangle. It is also forming a triangle. And both the triangles are in the same plane. So this can be viewed more nicely if I draw it like this. So this is Z plane and this is Y plane. In this plane, one carbon resides here, one carbon resides here, one hydrogen goes away, one comes closer, goes away, comes closer, and one sigma bond is there. Now this is sp3 sp2 hybrid orbital. These two are sp2 hybrid orbitals. sp2 of carbon is this, and sp2 of carbon, this carbon is this one. This is the overlap zone. This is the s orbital of hydrogen. S orbital of hydrogen. S orbital of hydrogen overlapping. Overlapping. So here we see these all are forming sigma bonds. This is a sigma bond. This is a sigma bond, sigma bond, sigma bond, sigma bond. Now from where this pi bond is formed then? In sp2 hybridization, 1p remains unused. So this unused p orbital above the plane and below the plane, they overlap and they form a pi bond. This pi bond is a weak bond, but electron rich bond because it contains electron cloud. So this electron cloud can be shown like this. Now we can draw it in this way. One carbon here, one hydrogen here, one hydrogen here. The other carbon here, one hydrogen here, and one hydrogen here. The pi cloud exists like this. Okay. So since p orbitals are double dumbled, so their overlapping will also be there above and below the plane. Okay. So their overlapping will be always above and below the plane. Okay. Although there are 2 points of overlapping, but the number of bond formed is only 1. Okay. So since p orbitals are double dumbled, they overlap above and below the plane, forming one pi bond. Again, similarly, we will see the structure of or the formation of alkynes. You can always refer to whatever is taught because of whatever I'm teaching, I do record and after that I put it in the YouTube. For class 11th and for class 12th, chapter-wise playlists are there. So you will not have to hunt for the videos. If you go and check the playlist, then check for the name of the chapter. In each of the name of the chapter, you will find that chapter-wise videos are there. Okay. So I will send you a few playlists for you to understand how the videos are organized. Okay. Although I started making these videos in lockdown, I will continue to prepare the videos of NCRT solutions, theories, and even the questions of competitions. This will continue. So you can always follow this because chemistry has no end. So discussion will keep on continuing. You can always ask and answer. So we'll see the structure of alkynes. Formation of alkynes. In alkynes, what happens? Triple bond is there. Now, in this triple bond, the pi bond is above one here and one here. So, as I told you that one pi bond is there above the plane and below the plane, then the second pi bond, in which plane will it be? Okay. So, for this, let us try to see a three-dimensional plane. Now, see the irony of the connotation. Three-dimensional plane. Okay. So, let me make one three-dimensional plane. It is one-dimensional plane. Let me show you three-dimensional plane. This is three-dimensional plane. Now there is a reason why I have drawn this kind of a plane. The reason is you will come to know very shortly. So if one carbon is here, another carbon is here, one hydrogen is here, and one hydrogen is here. So it is forming sp hybrid orbital. So if it forms sp hybrid orbital, then it's py. It will be px. It's py, and pz will be pure. They will be pure p orbital, which can form pi bond. Now one pi bond we have understood very well. That one pi bond will be there above the plane and below the plane. This was one pi bond. This was one pi bond. Now where will be the second pi bond? Second pi bond will be in the z axis. This is y axis. Of py. Similarly, in z axis, pi bond can be formed. Like this. This is z axis. So due to the formation, due to the presence of the pi cloud, due to the presence of pi cloud, of electrons, in y-axis and z-axis, a cylindrical arrangement of electron cloud is formed. A cylindrical cloud of pi electrons are seen. It is like this. A cylindrical cloud of pi electron so in this way alkynes are formed. Its orbital picture will be this one. This can be drawn even more clearly. Okay. The pi clouds in y plane or y axis and z axis forms a cylinder like shape. And it is a linear molecule. Its bond angle will be 180°. This can be drawn even more clearly if I draw in this way. One carbon, another carbon, this is the sigma skeleton. One pi, this is one pi bond, and another pi bond could be shown like this, forcefully shown like this. So only we will show in one side, we will not show on the other plane. So it is the axis of the molecule. It is linear molecule. It has a sigma skeleton, and these are the pi clouds in z axis, and this is pi cloud in y axis, because pz and py is pure p orbital and hybridization is sp hybrid orbital, such that px is utilized in this. So this was about structure or molecular orbital picture. Now we'll see a few reactions. One more is there, aromatic compound. Orbital picture of benzene. This is how we write benzene. Sometimes we don't show this hydrogen also because these hydrogens are there. It is understood because each carbon should have four bonds. Each carbon should have four bonds. One, two, three, four. So these are understood that these are carbon and hydrogen. So we draw this molecule as simple as just like this. We draw it. Either double bond will be here, here, or here, or it can resonate. Double bond can be here, here, or here, and we can draw its resonance hybrid structure as like this. So these two are canonical structure. This is resonance hybrid. Now the orbital picture is such that since it is double bond, so this carbon is sp2. Since it is double bond, this carbon is sp2. Since it is double bond, this carbon is sp2. So what happens? Its sp2 orbital overlaps like this. One is triangular planar. This is triangular planar. This is triangular planar. This is triangular planar. So in this way, each sp2 hybridized carbon forms trigonal planar arrangement in a cyclic form. So since it is sp2, that means spx and spy is used and pz is pure. This pz orbital takes part in in formation of these pi bonds. One pi bond, two pi bond, and three pi bond. How? Like this. Now sigma skeleton is understood. I can only draw the skeleton here. Now above and below the plane, there is pz orbital. Above the plane, below the plane. 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 Now, these and these can inclined and overlap. These and these can inclined and overlap. And these and these can inclined and overlap. If it does so, then this pi bond will be formed due to this lateral overlapping. This pi bond is formed due to this lateral overlapping, and this pi bond is formed due to this lateral overlapping. So this lateral overlapping can also change. This and this can also overlap. This and this can also overlap, and this can also overlap. That is why the structure is drawn in this way. That the pi electrons can be here also, here also, here also, or it can be here also, here also, and here also. So these two are canonical structures. and together they can be written as, this is called as resonance hybrid. These are canonical structures. They are undergoing resonance, and there can be a diagram or there can be a molecular formula which can represent both. It is called as resonance hybrid. Canonical structure means similar structure, and resonance hybrid means if a molecule can exist in more than one or more than one canonical structure, then the structure which represents which represents all the canonical structures is called resonance hybrid. So this was all about structure of the hydrocarbons. We had seen conformational diagrams, we have seen orbital picture, we have seen sigma skeleton, we have seen pi skeleton. Now we will see a few reactions tomorrow, means on Monday. All right, reactions of aliphatic compounds and reactions of aromatic compounds. Okay, so by Monday and Tuesday this chapter will be over, and then we'll be starting hydrogen, then S block element, and then P block elements. Thank you.